Chapter 17 deals with kind of the hazards that we face, environmental hazards, and how those affect our health. The case study that opens up this chapter deals with BPA, which is maybe something you've heard of. A lot of things now advertised as being BPA free, but this will be referenced again and again. Still no federal laws that or regulations for BPA, but there are several state laws, and a lot of companies voluntarily eliminated BPA from products, especially with children. So we're going to talk a lot about the issues surrounding BPA in this chapter. So chapter 17 starts off with kind of looking at risk assessment and risk management. It's important to keep in mind that most people are not very good at risk management. We tend to overemphasize kind of the sensational and highly unlikely risks like shark attacks, and we underemphasize the actual major risks like heart attacks. We basically face a whole bunch of different hazards like biological, chemical. There are natural hazards, fires, earthquakes, floods, cultural hazards like unsafe working conditions, poverty, crime, and then also lifestyle choices. So things we do that aren't so great for us. Let's look at biological hazards. That's 17.2. So infectious diseases are any disease that's caused by a living organism, bacteria, virus, parasite. Many times infectious diseases are also transmissible or contagious, so they can be spread from person to person. We contrast that to non-transmissible diseases. These are not caused by organisms and they don't spread. So something like cancer, for example, or heart attack. So figure 17.3 here shows some of the ways that infectious disease can spread. So some of the vectors that can carry disease, like insects with malaria that carry that parasite, the deer ticks that carry Lyme disease, etc. Two terms that you probably have heard of before. An epidemic is a large-scale outbreak of a disease. A pandemic is a global epidemic or a global outbreak. And then you can see here in 17.4 the deadliest infectious diseases, and one that we might underemphasize is pneumonia and flu, which are caused by bacteria and viruses. So it's a good time to get your flu shot if you have not done so already. Gets into antibiotic resistance. So remember back to biology and natural selection. So, and this science focus looks at MRSA. Then there's also a case study about drug-resistant tuberculosis, which has been becoming more and more problematic. Viral diseases oftentimes are some of these newest or emergent diseases. West Nile virus, Zika, Ebola, avian flu, SARS, those have all been in the news recently. And usually with most of these emergent diseases, they are first transmitted from animal to person. So if we think about as the human population grows and we have more interaction with wild animals, so we kind of encroach upon their space, that increases the likelihood that these emergent diseases could pop up. And then they spread from person to person. Okay? And this science focus looks at kind of how we can track the spread of diseases from animals to humans. Some really interesting case studies here about HIV and AIDS, which we mentioned a little bit in chapter 6, and malaria. Malaria is one of those things that we don't think about here in New England, but some parts of the world it's a major issue. So figure 17.6 shows all the areas where malaria exists. And one of the simplest solutions for malaria is something like a bed net. And that's where it gets complicated, because like DDT, which we know is a persistent fat-soluble pesticide, so it bioaccumulates, it biomagnifies, but it also it's very effective. It does a good job of killing off mosquitoes. So do you use DDT? Yes or no, right? Some different things to think about there. 17.8 shows some nice solutions that could reduce the spread of infectious diseases, and that could lower death rates. So if we want to tie this back into chapter 6, those could all be useful there. So read through those. Those are all biological hazards. 17.3 deals with chemical hazards, so kind of the toxins that we're exposed to. Can be divided into 3 major categories. Carcinogens are things that cause cancer. Mutagens cause mutations, right? Changes to the DNA. And then teratogens are things that cause harm to fetus or an embryo. Nice case study here about PCBs, which maybe you've heard of before, maybe not. They are carcinogenic and teratogenic. They are persistent, so they do not break down easily, and they are fat soluble, so they can bioaccumulate, they can biomagnify. So, even though they've been banned for a long time, they're still around. So that's a problem. Chemicals can affect different systems. They can affect the immune system, and then that can have problems because once the immune system is weakened, people are more susceptible to things like pneumonia and the flu. Some chemicals are neurotoxins. They affect the nervous system, and then some are endocrine disruptors. They affect the endocrine system, which is basically all of your hormones. Okay, these are sometimes also known as hormonally active agents. Definitely read the science focus on page 448, focusing on mercury or methylmercury as a neurotoxin, a teratogen, and then figure 1710 gives you some nice prevention versus control methods that can be used with mercury pollution. And really important to point out here too, that mercury is a natural substance, right? So a lot of times people think, oh, things that are natural are fine, and things that are synthetic or made by humans, those are the bad things. But there are a lot of things like mercury and lead, for example, that are very dangerous even though they occur naturally. And then there's a lot of information here about endocrine disruptors. And the thing that's interesting about endocrine disruptors is we still have a lot to learn about them. And BPA, which is an endocrine disruptor, could be controlled under the Toxic Substances Control Act. Problem with this is TSCA has a really high burden of proof, so it's maybe not the most effective way to regulate something like BPA. We'll get into that later on in this chapter. In terms of evaluating chemical hazards, we look at toxicity, how harmful a substance is. And a lot of this comes down to dose. Okay, so there's a phrase, the dose makes the poison. So anything pretty much can be toxic given certain amounts. So it's like, how much does a person need to be exposed to for the toxic effects to take hold? And that can be affected by a lot of things. When we look at responses, that's the damage to the health from exposure to a toxic compound. Acute responses are immediate or rapid harmful reactions. So dizziness, headache, difficulty breathing, possibly death. Chronic response is permanent or long-lasting consequences. So things like kidney failure or kidney damage, liver damage, etc. That isn't going to go away. Children and infants are more susceptible to toxic substances. The three main reasons: they take in, per pound of body weight, more air, more water, and more food than an adult. So they're exposing themselves to more right there. They put their fingers and objects in their mouths. This is why lead paint in a house, if it's all adults, not really a big deal. But kids will do things like chew on windowsills, and there'll be little flecks of paint and their toys are in them, and they put their toys in their mouths, etc. And they also have less well-developed immune systems, and their bodies are not quite as good yet at filtering out toxins. So that's what some scientists say. Children and infants could be anywhere from 10 times to 100 times more affected by toxic compounds than adults. When looking at toxicity, oftentimes you see a dose response curve, which we can see in figure 1713, and oftentimes they refer to an LD50 or lethal dose 50, basically the dose of that compound, that toxic compound that kills 50% of subjects in a test group. So we often use LD50 results when looking at animal testing. And then there are a lot of other ways that you can potentially estimate how harmful chemicals are, and that's discussed a little bit here. I don't know that you need to know that as much, but definitely understand what an LD50 is. Figure 1715 can just try to make you paranoid, showing you all the different things in your house, very common items that expose us to trace amounts of potentially toxic chemicals. And there's not a lot known about how harmful are these things. So that's just something to think about. Really don't become paranoid, because that won't be helpful. But just be aware that a lot of things that contain, flame retardants and different chemicals could potentially have effects, especially if with trace amounts of exposure over very long periods of time. Talked about how TSCA has kind of a really high burden of proof. If we can contrast that to the precautionary principle. So precautionary principle, which was first introduced in Chapter 9, basically when there's a significant uncertainty about potentially serious harm, you should act to prevent harm to humans or the environment. In other words, for chemicals, for example, prove that they're safe, not that they're toxic. You can imagine there are a lot of people who would be opposed to the precautionary principle. Europe tends to operate more under the precautionary principle than the United States. So that's why you might hear that, this is banned in the European Union, but not banned in the US. Right or wrong, just how they operate. One thing that in Europe they've really been working on is the persistent organic pollutants, or POPs, things like DDT, a lot of other pesticides, PCBs, dioxins, the things that don't break down. And then the last section of Chapter 17 kind of highlights what are the greatest health risks. Poverty, which leads to malnutrition, can weaken immune systems, people who live in poverty are more susceptible to transmissible diseases, might not have clean drinking water, etc. Those are all problems. Lifestyle choices. This is especially true in the most developed countries, where obesity, for example, is a major problem. Tobacco, of course. And then gender. Sorry, guys, just being born male reduces your lifespan in the United States by about 7.5 years. That's unfortunate for you guys. And then kind of going into, again, evaluating risk. Not something that I think you need to really focus on in terms of the calculations that they show, for example, on page 461. But do know that we're bad at evaluating risks. We're really bad at it. So it's good to educate yourself.